Alright, we are looking at our exterior angles and angle sum theorem 5.05 SBW. Let's first start with a practice problem that outlines what an exterior angle ought to be. Take a moment and see if you can identify which of these would be an exterior angle. You should have selected this option here as your exterior angle. Let's explore what an exterior angle is and identify specific exterior angles in a few triangles. So in this example, we have a triangle on the right, and we want to identify first what the word exterior means. One way that you could define it is it means outside of something. So you're outside of some object or something. But we want to put it in the context of our triangle here. So what are exterior angles? Well, exterior angles are angles that lie outside of or are formed by or formed outside of a polygon. Now I want to be a little bit more specific than that. So I'll put it in parentheses. There's really two things you need. You need a normal side and an extended side. Let me explain what that looks like. So over in the diagram on the right, we can identify the exterior angles. They are the numbered angles: angle 1, angle 2, angle 3, angle 4, angle 5, and angle 6. Those are the exterior angles. Notice, however, that we also have angles that happen to not be exterior by definition. Here's the reason why they're not exterior. The reason they're not exterior is because they were not formed by extending the side length of a triangle and pairing that up with a normal side length to create an extended or exterior angle. So angle 1 and 2 are created by extending one of the side lengths of the triangle and the normal side length of a triangle. Same thing with angle 6. It's created by that extended side and that normal side, this normal side and that extended side. And again for 3, this extended side and that normal side, this extended side and that normal side. And so that represents what an exterior angle is in the triangle. And there's a couple observations you can make with this, but I'll first point out that please notice how many exterior angles each vertex actually has. So I'm already kind of giving you a little bit of a hint on one of your SBW questions. Each vertex has 2 exterior angles. 2 exterior angles. Okay, so that is how you create an exterior angle in the context of a triangle. So what I would like you to do is pause the video and see if you can select the correct option for what the exterior angles are in this case. You should have selected this last one here. If you look at 7, I can extend this side and I can create that angle there between that normal side and the extended side. I can extend this side right here, and with that extended side, let's straighten that up a bit there. I can create angle 16, so that is an exterior angle. And then, of course, I can go ahead and extend this side on this side over here and create an angle between the normal side on the bottom and the extended side. That's an exterior angle. The other 3 angles are interior angles, so they cannot be exterior at all. I only have referenced one of the 2 angles that each vertex actually has. If I wanted to write out more of these, I could certainly do that. For example, if I extended this side out this way, then I would have created an 18th angle that would also be exterior. If I extended this side out this way, I would have created a 19th angle that would have been exterior. And there's already an extended side that goes out here, so that certainly could represent another exterior angle. And as you can see, we have 2 for each vertex, as I mentioned before. So in this case, you need to know what a vertex is, right? So we know that this best represents a vertex. A vertex is going to be best defined as the location where two or more lines meet, right? So we can specify that as a point, right? It's the point where two or more lines meet. So you have to have two or more lines intersecting each other to create a vertex. Of course, triangles have three. And we can see here that there are two exterior angles, as I've said now, really kind of for the third time. There's two exterior angles for each vertex or point of a triangle. And in this case, the exterior angles that belong to angle 2 would be the ones that are shaded in green. Remember, I'm going to highlight this in orange. Not an exterior angle. Not an exterior angle. Not an exterior angle. Those are not exterior angles at all. Pause the video and see if you've been paying attention. How many exterior angles does each vertex of a triangle actually have? You should have selected 2, okay? 2. A couple examples, not all examples, but a couple of them. You've got 9 and 7. You've got 4 and 1. 16 and 17 are a couple others as well. So just keep in mind, depending on the triangle you're looking at, that'll determine how they're exterior, why they're exterior, what are they? They're the angles formed by an extended side and a normal side of that triangle. That is how you create them. There's just a few of the ones that we see right there. Okay, so which of these represents opposite angles? Well, in this case, we should select the final one. That is an angle pair that you should recognize. The opposite angles are called vertical angles. Vertical angles. So this is an old angle pair, angle relation that we've already discussed before. In our case, the vertical angles would be 1 and 3, 2, and 4. And what does that mean? Well, that means that they are congruent. That's exactly what they mean. Vertical angles are congruent. So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. That's exactly what they mean. This would be very helpful in answering one of your SBW questions that you will find on your assignment. So in this case, what's the relation between 7 and 9? Pay attention to how 7 and 9 appear. 7 and 9 are exterior angles to the triangle. They're formed by an extended side and a normal side, but look at them. They're opposite of each other, right? Because they're opposite each other like that, we should have selected vertical angles, right? So the relationship between 7 and 9 is vertical angles. All right. So, looking at that together, we also can determine, based off of a previous theorem that we looked at, how to find the missing angle in a triangle where we know 2 of them. So here's an example of that. We know that the sum of all the angles in a triangle adds up to 180 degrees. Angle A here is 100 degrees and B is 20 degrees. Okay, so I know that if I want to find the measure of angle C, I can go ahead and take the sum of the ones that I know, right? So 100 plus the 20, and subtract that from 180, and I get 60 degrees. So the measure of angle C is 60 degrees. You can also just say 60 and then degrees. Now, the theorem that's based off of that is known as the triangle sum theorem. The triangle sum theorem, sometimes referred to as the triangle angle sum theorem, or the more specifically triangle interior angle sum theorem. But that is a sum theorem for triangles that we use to justify that relationship. And here they gave me 2 angles that I knew, and I was missing the third angle. So I can just go ahead and use this theorem to find that value. Again, this would be very helpful on your SBW for one of your questions. So looking at this example, you can try the triangle angle sum theorem out. In this case, you should have arrived at 64.5 degrees. The two angles that are known in the triangle are here and here, and we're missing the triangle or angle highlighted in orange. So the measure of angle 15 is equal to 180 minus the two angles that I know of in the diagram. So that's 180 minus 115.5, and that is 64.5 degrees. So that is the degree value for the measure of angle 15. So looking at your SBW, we know that we can name the exact exterior angles represented in our triangle. Go back to my slide where I specifically define how we look at that. Remember, we talk about needing an extended side, so take a side length and extend it, and then you can create an angle with that extended side and a normal side. That's what's going to make an exterior angle. However, it's got to be between an extended side and a normal side, and we want to be a little careful because straight angles aren't necessarily going to produce exterior angles. We want to make sure that it forms that linear pair relationship with the vertex next to it as well. That's another way to think about it. Number two, how many exterior angles does each angle of a triangle have? There are several slides in our presentation that answer that question. I again encourage you to go back to near the beginning where I went through some of those examples and I talked about exactly how many each vertex is supposed to have. Number three, you're looking at the relation between 8 and 6. I would encourage you to refer back to slides like the ones that I referred to, for example, in the 14th and 15th slide. I'll just name the slides out, and let's see if you paid attention. What type of angle relation do 8 and 6 have in common? What is their relationship for 8 and 6? And then what is the meaning of that? You have to tell me what the relationship actually is beyond just what type of angles are they, right? So think about type of angles, and then what is that property that they have. And then lastly, you are missing an angle in the triangle, but you are given two other angles already. You have angle 1 provided and you have angle 2 provided. So you should be able to refer to the most recent slides prior to this slide, the last few slides I went over, to help you with this particular last question of your SBW. That is going to represent your SBW help video for 5.05.